Here we have an example of a function that requires the use of the product rule here. What it says is y equals the natural log of 5x squared plus 25 multiplied by 3x plus 4 to the power of 6. I want you to find dy by dx. So pause the video and complete this one. Okay, good. You're done. Now, let us go through it. Y is equal to this multiplied by this function, two functions here. Suppose we make u be this function and v this one. Then what we have as a product rule says dy by dx is equal to u dv by dx plus v du by dx. Now, since v is equal to 3x plus 4 to the power of 6, what is dv by dx? Here, you can use the chain rule to do this one because it's a function within another function. All right. So if you consider this function here as, let us call it a. Let us call it a. Then dv by dx is going to be, well, in this case, v. Let me backtrack a bit. V is equal to a to the 6, while a is 3x plus 4. You see that? So, dv by dA is equal to, or dv by dx, I should say. dv by dx is equal to dv by dA times dA by dx. In this case, dv by dA would be 6a to the 5th, and this time dA by dx would be 3x, no 3, just 3, not x, just 3. You can see it. Alright? So what would this give you? It would be 6 times 3x plus 4 to the 5th by 3. So you could say 3, 6, 18. So what you have is that this is equal to 18 by 3x plus 4 to the 5th. Alright. So that is dv by dx. So it is 18 3x plus 4 to the power of 5. Let's erase this. All of this we have here. Now the thing is, what you could do, right, once you're very much accustomed to using the chain rule, you could just say it is 6 times all of this, 3x plus 4, it's 6 times that to the power of 5 times the derivative of what you have here, which is 3. So times 3. So you have 6 3s 18 by 3x plus 4 to the 5th. Alright? Once you have a lot of practice with the chain rule, you don't necessarily have to write down the a equal or whatever number equal this, and then the v by dx is this and that and the other. Alright? You could picture the functions in your mind. Alright. Now, that is dv by dx. What is du by dx? Again, we use the chain rule. U is equal to all of this. Alright? Now, what you see is ln of something, whatever that is. When you find the derivative of ln this, what you have is 1 over it. 1 over 5x squared plus 25. And then that will be multiplied by the derivative of what you have inside the bracket. Again, chain rule. So it is 2 by 5x. You could do it by substituting one function at a time using a new letter, right? But you will see that what you have is ln of a function. When you differentiate ln of a function, you have 1 over the function, which is this. And then it will be multiplied by the inside function, the derivative of the inside function, which is 5 by 2x. Alright, so therefore the u by dx is equal to this, which is 2, 5, 10, is 10x all over 5x squared plus 25. So that's du by dx. So what we have here is du by dx, and what we have here is dv by dx. So putting these things together now, what do we have? dy by dx is equal to u, which is ln 5x squared plus 25 times, and then we have dv by dx. Alright? I have to be squeezing everything in a corner, but we'll write it out eventually. Just that we have limited space. So this is multiplied by 18 3x plus 4 to the 5th plus, then we have v, which is 3x plus 4 to the 6th times the u by dx, and the u by dx is 10x all over 5x squared plus 25. Alright, so in this case we can just write out everything all at once here. So the answer we get is this: dy by dx is equal to ln 5x squared plus 25 times 18 3x plus 4 to the 5th plus, this will amount to 10x by 3x plus 4 to the 6th all over 5x squared plus 25. Okay, so this is a complicated one, right? But once you practice it, then you become more and more comfortable with working these out using the product rule. Alright, so I'm going to end this video here, and I'll see you in the next video.